This video is brought to you by water, bringing life since when life started. Alright, let's get to some proofs. Alright, party people, let's get started. We're going to do a couple proofs today. Here's our first proof. It's a geometric proof. Just kidding, no, it's an algebraic proof. And so let's go ahead and jump in to some algebra. Okay, so notice there's no statement, there's no reason. We're going to do all of this freestyle. Alright, so we're going to go ahead and write our first piece here. And I'm actually going to do all of this a little differently. Since we don't have any pieces involved, I'm going to go ahead and besides that first one, statement and then reason, let's go ahead and just solve this. So I'm going to, right here, we're going to get rid of the 5 by multiplying to both sides. So this is going to be 2x minus 9 equals 5. So since I multiply to both sides, we're going to use multiplication property. Then I'm going to add 9 to both sides. And we're going to get 2x equals 14. So that's addition property. And then step 4, we're going to divide by 2 on both sides, and we're going to get x equals 7. And that's division property. Okay? Key thing here is we must end, always our last statement should match our proof. Okay? So always make sure we do that. And I think algebraic proofs you guys are pretty good at because you've basically done them before. And let's get to a geometric proof. Alright, number 2. I would like you to try this one, so if you want to pause the video, go for it. Now before I start this one, I'm going to think about it. So I'm going to actually cover this up for a second. And I see AC is equal to BD, so I'm going to go ahead and use some colors here. So we got purple, 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 purpley, purpley, purple. AC equals BD. That's fun. And then I want to prove, so I'm going to try and prove that this segment is congruent to this segment. Okay, so, well, what I can see here is BC is congruent to itself, right? And so if I cover that piece up, then I can see that the other two segment tails should equal that AB and that CD. So let's go ahead and see if we can take this step by step. Alright, AC equals BD. Now I do like to cover this up. I don't get ahead of myself. And sometimes getting ahead of yourself can get confusing. So how do I know AC equals BD? Well, everyone's favorite line, that is given. Step 2, AC is AB plus BC. So here's AB, here's BC. So the whole segment adds up to 2 smaller segments. That's called segment addition postulate. Okay, segment addition postulate. Yes. Oh, I didn't even see that BD was there as well. Hilarious. Alright, moving down. Let's make sure we get all the way. So, up, yeah, there we go. Now it says AB plus BC is equal to BC plus BD. Okay, so how did I do that? Well, you see how we said that these two are equal to each other? And then I said AC equals this and BD equals that? Well, I basically took this equation here, but instead of writing AC, I wrote what AC equals, and instead of writing BD, I wrote what BD equals. So we would call this substitution. Da, 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 da. Yes, this is substitution property. I substituted the values in for AC and BD. Next, how did I get from here? Well, do you see how I subtracted BC from both sides? And we talked about how BC is equal to itself, right? Just like that. And so that's subtraction property. And we are done, because our proof is right there. And we ended it. Yeah, 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 yeah. Alright, let's get to angles. Number 3. Tree on the tree, on the tree, on the tree. Tree, tree. Alright. Measure 1 equals measure 2. Angle 1 equals angle 2. Angle 3 equals angle 4. Angle 3 equals angle 4. Okay, show that ABC is equal to DEF. Well, if these two are the same, obviously this piece and this piece are going to be congruent, right? Okay, because if that's 30 degrees, that's 30 degrees. If blue is 40 degrees, that's 40 degrees, which means this would be 70 and that would be 70. So this makes logical sense. So let's take this step by step. All right, part 1, angle 1 equals angle 2, and angle 3 equals angle 4, our favorite, given. Okay, part 2. Angle 1 plus angle 3 equals angle 2 plus angle 4. How'd I get that? Well, do you see how this original statement is angle 1 plus angle 2? And do you see how it's right there? Well, if it's true that 3 equals 4, do you see how I'm just adding 3 and 4 to this original blue equation? So if I'm adding the same thing from one side to the other side, it keeps my equation balanced. Okay? So this is actually addition property. Because I just added these two pieces to my original blue equation, and that's how I got 3 and 4 added in there. Well, the measure of angle 1 and 3 is ABCE, angle, and measure 2 and 4 is angle DEF. And so these two angles, that is the definition of, or not definition, sorry, the angle addition postulate. And then last but not least, instead of writing 1 plus 3 right here, we can write ABCE. So instead of doing 1 plus 3, I'm going to say it's ABC. So basically these two are substituting in for each other, right? And then instead of saying 2 and 4, I'm going to plug in DEF, because DEF equals 2 plus 4. So this would be substitution property. All right, nice. I just realized you couldn't try that one on your own because I never showed you the whole thing, so I apologize. Okay, last but not least, you're like, Mr. Smith, there shouldn't be a last one. You said 3. I know. I just want to show you this one number here, 4. Why don't you go ahead and try it? I want you guys to try it, and we can talk about this one when we meet up. This one should look pretty familiar. Okay? All right. All right, well, that's the end of the video. Thanks for sticking around and watching. I hope you guys have a great one, and I'll see you next class, okay?